Here we have a problem on radical and exponents. Okay, let's consider the stuff over here. That is cube root of x positive cube root of y positive cube root of z equals to 0, and we have to find the value of this one. Okay, let me assign a new variable for each one of these three terms. So that is let a equals to cube root of x, b equals to cube root of y, and c equals to cube root of z. Then this equation will become, we can plug in a for this cube root of x, and for this one we can plug in b. For the last one we can plug in c. We get a positive, b positive, c equals to 0. So in algebra there is a concept whenever a positive, b positive, c equals to 0, that is the addition of three quantities equals to 0, then we can say a to the third power positive b to the third power positive c to the third power equals to 3 times a times b times c, that is 3abc. Okay, so we can use the stuff over here in our problem. So since a positive, b positive, c equals to 0, we can say that a cube positive, b cube positive, c cube equals to 3abc. Okay, now actually a, b, c are the variables taken by us. So now it has to be replaced by the original stuff. That is, for a we have to plug in cube root of x, for b we have cube root of y, and for c we have cube root of z. Let's plug in. So for this a we can plug in cube root of x, and for a we have exponent 3. The same exponent should be taken over here, positive. For b we can plug in cube root of y, and we have exponent 3 for b, and for c we have cube root of z, and for c we have cube for 3, and 3 times. So for a we have cube root of x, for b we have cube root of y, and for c we have cube root of z. Okay, here x to the power, whenever we have cube root, it can be written as exponent 1/3. So x to the power 1/3 to the power 3 positive y to the power 1/3 to the power 3 positive z to the power 1/3 to the power 3, and 3 times the same thing we can do over here. So x to the power 1/3, y to the power 1/3, and z to the power 1/3. Okay, let me continue this on the next page. This is the last step we had on the previous page. Okay, let's do further simplification. So here we have base x, and we have exponent 1/3, and for the complete stuff we have the exponent 3. Okay, whenever we have two exponents like this, we can multiply the two exponents according to the power of a power rule in exponents. So now we have to multiply these two exponents 1/3 and 3. The same thing we have to do over here. So y to the power 1/3 times 3 positive z to the power 1/3 times 3 equals to 3 times x to the power 1/3 times y to the power 1/3 z to the power 1/3. So here this 3 will cancel out, and 3 will cancel out, 3 will cancel out. Here we get x to the first part. It's nothing but just x, and here it's just y, and it's just z, and 3 times. And these 3 terms are multiplied, and all the 3 terms are the same exponent 1/3. So whenever 2 or more terms are multiplied with the same exponent, we can write the exponent in common, and we have to multiply the bases. Then I'll be getting x times y times z to the power 1/3. Okay, now I got the value of x positive, y positive, z. That is 3 times x, y, z whole to the power 1/3. According to the question, we have to find the value of the expression x positive, y positive, z over 3 whole cube. Okay, already we know the stuff for x positive, y positive, z. That is 3 times x times y times z whole to the power 1/3. So we can plug in this stuff for x positive, y positive, z over here. So then I'll be getting 3 times x times y times z whole to the power 1/3 over 3 whole to the power 3. So here this 3 will cancel out. I'm getting x times y times z whole to the power 1/3 again to the power 3. Okay, here we have two exponents. So the first exponent is for the base x times y times z, and for the complete stuff we have exponent 3. So whenever we have two exponents like this, we can multiply these two exponents according to the power of a power rule in exponents. So then I'll be getting x times y times z whole to the power 1/3 times 3. So I just multiply these two exponents. The 3 will cancel out. So I'm getting x times y times z whole to the power 1. So it's equals to x times y times z. So I got the value of the given expression, that is equal to x times y times z. Okay, now let's go back to the original question. Here we have the original question, and we got the value of this expression x positive, y positive, z divided by 3 whole cube, that is x times y times z. So the correct answer choice for this question is option A.